Okay, good day, Grey Nines. I trust that you are well. This short video is merely to explain the Nexus project for term 3. So, if we look at the Nexus project, it's a clear link between economics, management science, and mathematics. So, the content that you learn in EMS will closely link with your mathematics financial plan. So, for EMS, you were said to create a financial plan or rather a business plan for your electrical system business. For mathematics, I will only assess the business or the financial plan of that. So firstly, let's understand two concepts. The first concept being fixed costs. So first, let's understand what is fixed cost. As the name suggests, it's fixed, meaning this is the cost that will not change. So if I produce 0 goods, I still need to pay this amount. If I produce or make one good or one product, I still need to pay this fixed amount. And a clear example of this is your rent or your lease agreement. Now let's say, for example, rent costs 5,000 Rand. Whether I produce one product, it is still 1,000 Rand. Or if I produce 5,000 Rand, if I produce two products, it's 5,000 Rand. If I produce five products, it's 5,000 Rand. If I produce 100 products, it's still 5,000 Rand. The rent is fixed. It's not going to change. Every month, I'm still going to pay 5,000 Rand. So you can look at more examples of your rent agreement, but you can include salaries. If I have employees in my business, and for one employee, I will pay him 10,000 Rand a month, right? If I hire one employee, the next month I'll pay him 10,000 Rand. If I produce 1,000 products, I'll pay him 10,000 Rand every month. If I produce one product, I'm still going to pay him 10,000 Rand per month. And that being said, those are my fixed costs. And you get other fixed costs as well. Some textbooks include depreciation and whatnot. So I'm just going to put etc. here because you will learn about your fixed costs in EMS. Then your business also has variable costs. And as the name suggests, these are the costs that vary. Right? The more of a product I produce, the more I will have to actually pay for fixed costs. And raw materials is a prime example of fixed costs. Raw materials. Now let's take an example, and there's other variable costs like delivery costs, packaging, and I'm just going to put etc. for now because there's other examples as well. So let's take an example, and this is just an example. According to your Nexus project, you have to create a financial plan based on a product from an electrical system, as you are doing in natural science as well, or as you are creating in natural science. Let's take an example. Let's say I have a book company. Right? Let's say I have a book company. And to produce books or to make these books, of course, it will incur quite a lot of costs, as you can imagine. It will incur specifically fixed cost and variable costs. So in my simple example, I say it's a simple example because I'm just going to use a few figures. In my simple example, let's say the only fixed cost I have for my book company is rent. That's quite nice. But in reality, and according to your Nexus project, you should include some other fixed cost as well, like salaries, and you can add all those fixed costs together to give you your total fixed costs. But let's say in my example, rent costs 5,000 Rand. So what is my total fixed cost? My total fixed cost will be the sum of all the fixed costs, and remember it's 5,000 Rand per month, right? What's my total fixed cost for the month? It's just 5,000 Rand in my example. In your example, it could be different, or in your Nexus project. Now, if my total fixed cost is 5,000 Rand, let's see my variable cost. Now, let's say in my example, I only have two variable costs. The first variable cost I have is paper, and paper is a raw material. That means the more books I produce, the more paper I will need. The cost of paper would increase. So therefore, paper is a variable cost as one part of raw materials. And let's say, for example, raw materials, or rather paper costs 2,000 Rand per month, right? It will vary, it could change. And the total amount of ink for the month costs 1,000 Rand, right? So these two are my variable costs. In an ideal world, in your example, there should be more. And I assume in a book company, there should be more as well. What about the glue to bind the book together, for example? What about the delivery costs to package it into nice packages for the consumer? And so forth and so on. But for my example, let's just say that there's two variable costs. There's paper and there's ink. So my total variable cost will be 2,000 Rand plus 1,000 Rand, which is 3,000 Rand. So my total, I'm just going to abbreviate variable cost as VC, is equal to 3,000 Rand. So my total fixed cost is 5,000 Rand. My total variable cost is 3,000 Rand. So my total cost will be equal to the total fixed cost plus the total variable cost. The total fixed cost is 5,000 Rand. The total variable cost is 3,000 Rand. So what is my total cost? My total cost is 8,000 Rand as such. Now I want you to assume, so according to your research, how much units will your business produce according to your research? Let's say the amount produced in my book company, or the units that I produce, right, per month. So for 1 month, let's say I produce 1,000 books, right? So let me just scroll that down so you can see it clearly, right? Let's say I produce 1,000 books. Now I need to calculate the total cost per product or per unit. Per means one. So I have my total cost per product or per unit. My total cost per product is equal to the total costs, which we just calculated as the total fixed cost added to the total variable cost, divided by the total amount of units you produce, or the amount produced, the amounts of units produced per month. Right? Remember, so it's total cost per month divided by the amount produced per month. Your total cost, we just calculated that to be 8,000 Rand. And the amount produced, we assuming that every month you produce 1,000 books. So it's 1,000 Rand, 1,000 books rather. So what is my total cost per product? So to make one product, it costs me 8 Rand. Just to make one book, the total cost is 8 Rand. Now, if it costs me 8 Rand to make one book, do you think I will actually sell that book for 8 Rand? And the obvious answer is no, I will need to make a profit from it. So my cost price is 8 Rand. I have a percentage markup and I have my selling price. Now, according to your research, let's assume what the markup is going to be. So in my book company, let's say the markup percentage is 50%. So I make a 50% profit from that. So my cost price is 8 Rand and my markup percentage would be 50% off, which means times 8 Rand, which is 4 Rand. So my markup is 4 Rand. And to get my selling price is equal to my cost price plus my markup. So my selling price is 12 Rand. So what does that mean? It means that it costs me 8 Rand to make one book or to produce one book, and I'll sell one book for 12 Rand. Of course, this is just merely an example. Now let's calculate the gross profit per product. So you would have learned that gross profit per product, right? Gross profit per product is equal to your selling price per product. I'm just going to abbreviate a bit. Minus your cost price per product. So my selling price per product is 12 Rand minus my cost price per product, which is 8 Rand. So what is my gross profit per product? It's going to be 4 Rand. So what does that mean? It means when I sell one book, I'm making a profit of 4 Rand for one product. Now, from that, I need to draw a graph. And the graph will show the relationship between the number of sales, the number of books sold, to the gross profit per product. So let's draw a table, right? So before we can draw a graph, let's draw a table. So I have, let me actually use the back of this page just to save some page. Right, so I have the number of sales, and I have the gross profit per product. I want you to think of this very carefully. Let's say I sell 0 books. What amount of gross profit will I make? I'll make 0 rands. I'll make 0 gross profit. Let's say I sell one book. I'll make 4 Rand gross profit. And where do I get that from? By calculations. I just saw that my gross profit for one product is 4 Rand. And you can do the math from here. If I sell 2 products or 2 books, I'm going to make an 8 Rand profit. If I sell 3 books, I'm going to make a 12 Rand profit. If I sell 4 books, I'm going to make a 16 Rand profit. If I sell 5 books, I'm going to make a 20 Rand profit. If I sell 6 books, I'm going to make a 24 Rand profit. And you get the point, and it can continue. My table can continue. For now, I'm just going to leave it as such. And based on this table, I'm going to create a graph. My x-axis is going to be the number of books sold. So that's going to be my horizontal axis. My vertical axis, my y-axis, is going to be the gross profit per product. And if you forgot, how do we plot a graph? First, of course, first of all, we need a title for our graph. So something simple will suffice, in my opinion. It should be something like graph showing, let's line this up properly. Graph showing the relationship between number of sales to gross profit per product. Gross profit per product, right? And of course, let me use my ruler so that it looks much more accurate. Right, so you're going to take your ruler and you're going to draw your graph. Right, so I have my vertical axis and I have my horizontal axis as such. So on the vertical axis, I have the gross profit per product. Okay, this is 0. And on my horizontal axis, let me scroll that up, I have the number of sales. Right. And since we measured in gross profit per products, we counting in 4s. Let me mark this as well. Please use your ruler and your pencil as accurately as possible when it comes to drawing graphs or plotting graphs. right? I have my y-axis, and I also have my horizontal axis. Right, so let's label that. Now, of course, my x-axis is fine. I can say 1, 2. If I sell one book, if I sell 3 books, 4 books, 5 books, 6 books, 7 books, 8 books, and 9 books, and this can continue. My y-axis, let's count in 4s: 4, 8, 12, 16, 20, 24, 28, and so forth and so on, and that can continue. So if I look at my table, it's very similar to a straight line graph. What I can do is I can create ordered pairs. And remember, a coordinate is always in the form of xy. First you have your x value, then you have your y value. So what are my coordinates? My coordinates are, let me write the coordinates at the bottom here. The first coordinate is 0, 0. Right? Then I have 1, 4. Then I have 2, and the x value is 2, the y value is 8. When I sell 2 books, I make a gross profit of 8 Rand. Then 3, 12, 4, 16, and the rest can continue, 5, 20, and so forth and so on. So let's plot these onto our Cartesian plane, or rather our graph to that extent. Let's plot that onto our graph. First we have 0, 0. First we have 0, 0. Then we have 1, 4. So let's try to measure this as accurately as possible, guys. We have 1 and the y value is 4. Then we have 2, 8. 2, 8. Right, somewhere there. Then we have 3, 12. Just bear with me. 3 and 12, right? Let's get this up. 3 and 12. I just have this object on the way, so it's kind of awkward to do. Yeah, there we are. 3 and 12. Then we have 4 and 16. 4 and 16 as such, and the coordinates can continue. So of course this is a straight line graph. All I'm going to do is I'm going to join plotted points together, and my gross profit per product should look something like this. This is my gross profit graph, right? And you can see when I sell 5 products, it goes up and I make a gross profit of 20 Rand per product, and it can continue in that fashion. Now it does not end there. Now we have to create a new graph. So I'm going to just keep this in mind. I'm coming back to it in a minute. Now on the same set of axes, we have to draw the graph of fixed cost per product. I might say, how do I calculate fixed cost per product? Let's calculate it now. We have fixed cost per product, right? Fixed cost per product is equal to the total fixed cost divided by the amount produced, right? So the total fixed cost, if you can recall from a few minutes ago, we said that the total fixed cost is 5,000 Rand in my example, because that was the amount of rent, and that in my hypothetical example, that was the only fixed cost we have. And the amount produced, we said that we produce 1,000 Rand a month. So what is my fixed cost per product? It's 5 Rand. So let's draw a table. We have the number of sales, which is my x-axis, and on the y-axis we have fixed cost per product, which will be the same Rand value as the y-axis for gross profit per product. So let's say we make 0 sales. What is my fixed cost per product? It's 5 Rand. So if you said 0, that's incorrect. Why? Because fixed cost per product is fixed. It does not change. It will always remain as 5. Right, if we sell 1 product, the fixed cost per product is 5 Rand. If we sell 2, it's 5 Rand. If we sell 3, it's 5 Rand. If we sell 4, it's 5 Rand, and you get the point. It will be 5 Rand throughout. It does not change. So let's look at our graph again and let's plot these points. So of course the coordinates for this will be 0, 5, 1, 5, 2, 5. So it's clear that this graph will not have a gradient. The gradient will be 0. It's just basically a straight horizontal line, and that is what your fixed cost is. It's basically a horizontal line. So let's plot that. Let's say 5, because I counted in 4s here, it's quite awkward, but let's say 5 is somewhere here. Right, 5 is somewhere there. So I'm going to use my red marker and I'm going to draw this horizontal line. So my fixed cost graph should look something like that. Now this is the graph for fixed costs. And the equation is quite simple. It's y is equal to 5. Always give your graphs an equation. And we need to find the equation of this graph, by the way. We still have to come back to that. Now this point here, if I had another color marker, it would be great. But this graph, this point here, this point when the fixed costs per product graph and the gross profit per product graph intersect, this is called the break-even point. I might say, what is this break-even point exactly? It's when the business breaks even. So if the business is able to sell more than this amount of products, right, then the business has made a profit. If it sells less than this amount of products, then the business has made a loss. This is the perfect break-even point. Any more sales beyond this point, the business has made a profit. Any sales below this point, the business has made a loss. So how do we calculate that amount? Now, we can use the graph, but we want to solve it algebraically, and that's what our Nexus actually requires us to do. So this is the fun part because this is very math related. So given the coordinates that we have, we already have the equation of this graph. We need to find the equation of the gross profit per product graph, and we can equate the two graphs to find this point of intersection. So how do we find the equation of that graph? Let's look back at our table. Remember, to find an equation, we need at least two coordinates. So we can use any two of the coordinates from the table, right? We can use any two coordinates from this table. My graph, right, for gross profit per product is a straight line. What do we know about a straight line? The standard form of any straight line graph is y is equal to mx plus c. Any straight line graph, that is the standard form. So likewise, the equation of the graph has to be in that form. So let's find m first. So if you can recall, m, which means gradient, is the change in y over the change in x. It's the change in y over the change in x. This triangle basically means change. So as I said, we need two coordinates. Let me just use from that table 1 and 4 and 2 and 8. You could have used any two coordinates. Now to find the change, let's call the first coordinate x1, y1. And let's call the second coordinate x2, y2. So now let's calculate the gradient of this straight line. It's the gradient is equal to y2 minus y1, that's basically the change in y, over x2 minus x1. So y2 is 8, let's substitute in brackets just to be safe, minus y1, which is 4. Why am I substituting in brackets? Now, of course, it's pointless substituting in brackets, but sometimes a coordinate can be negative when we looked at the Cartesian plane. But for now, I just got into the habit of just substituting in brackets, so it's quite nice. So I have y2, which is 2, minus x1, which is 1. So x2 rather is 2, and x1 is 1. Now, what is the gradient equal to? 8 minus 4 is 4, 2 minus 1 is 1, so 1 over 4 is 4. My gradient is 4. But remember, my standard form, if I can do it inside here, it's y is equal to mx plus c. I found the m value, which is 4. So it's y is equal to 4x plus c. I need to find the y value. So what I can do is substitute any coordinate, even those other coordinates that I have on this page here. Right? I could substitute any coordinates in the form of x, y. But let's substitute this value, 1 and 4. So I'm going to substitute 1 in the place of x, and I'm going to substitute 4 in the place of y. So I have, let me use some color for that now. Right? So what do I have? I have 4. It's equal to 4 into 1 plus c, which is 4 is equal to 4 times 1 is 4 plus c. So it's 4 plus c is equal to 4. C is equal to 4 minus 4. And you get the point. I'm doing too much here, but c is equal to 4 is to 0 because 4 minus 4 is 0. So what is the value of my graph? It's y is equal to 4x plus 0. So it's just y is equal to 4x. What I'm going to do is I'm going to go back to my graph. Right, I'm going to go back to my graph and I'm going to label it y is equal to 4x, because remember your graph has to be labeled as well. So this is perfect. This will give you your marks. But now we need to algebraically solve this point of intersection. So I'm going to equate the two graphs. Right? So if you can recall the equation of the g of x graph, the GP graph, the gross profit per product graph, was what? Y is equal to 4x. We just calculated that. And we know the equation of the fixed cost per product graph, of fixed cost per product graph. And what was that? That was y is equal to 5. Now we can equate the two graphs together. And how do we do that? Because both are equal to y, we can say 4x is equal to 5. So that will give me the x value where the two graphs intersect. So I have 4x is equal to 5. And this is just simple algebra. I divide both sides by 4. X is equal to 5 over 4. And in decimals, x is equal to 1.25. But you might ask me, how can I sell 1.25 books? It's a decimal amount. So let's approximate it. We need to sell approximately 2 books. Please don't round down. We're quite tempted to say 1 book. But what about the quarter? We have to include that quarter as well. So we need to sell 2 books. So therefore, my final statement, let's write a nice English sentence, although this is math. We can say, therefore, we need to sell 2 books in order to break even. So if I look at my graph, now I can go back to my graph and I can see that this point here is actually 1.25. But of course, we use 2 as the point because it's very unlikely for a book to be 1.25. I mean, imagine selling 1.25 books. Doesn't make any sense. And this was basically your Nexus project. This is what's required from you. So I hope that this video was informative and I wish you all the best for your Nexus project. Thank you.